Hi everyone! For this chapter 6 entitled The Human Population and Its Impact, I will be your first presenter, and the main question in this topic is how many people can the earth support? We will answer that question all throughout this presentation. Let's start with this term demographics. This simply means the study of human population. The present understanding of demography makes it possible to project population changes for decades into the future. It focuses on human population, which is the whole number of people occupying an area such as a country or the world, and continually being modified by increases such as birth and immigrations and losses through deaths and immigrations. In the past 50 years, human population has increased exponentially. So in this projection, it shows here that it took humans 150 years for the population to reach 1 billion in 1850. Then only 100 years later, in 1950, the population hit 2.5 billion. It then just took 60 more years to reach 7 billion. So in 2020, last year, the global human population reached 7.8 billion people. And this phenomenal growth is mostly due to something advanced, which is the medicine. And as of May 2021, the world's population is already 7.9 billion people. The United Nations estimates that by 2050, there will be 9.7 billion people, and in 2100, 11 billion people. So why our population has grown so quickly? We have here three main reasons. First, humans have the ability to expand or move into new habitat and climate zones since we can adapt environmental changes. Second, early and modern agriculture has allowed us to produce food very efficiently and in large quantities. And third, the control of infectious diseases. This is the biggest influence we have right now. Death rates are decreasing because of improved sanitation and healthcare. This is also the development of vaccines and antibiotics. As the population grows, resources need to be available to meet the needs of the people, such as land for housing and agriculture, sanitation and healthcare, and access to clean water. And according to Edward Wilson, a sociobiologist, the common limiting factor is freshwater and arable land. Look at this global land use for food production data. We see right here that 71% of the total land area is considered as habitable. So in this land, 50% is taken by the agriculture, which is for livestock and crops. And we see over right here that only 1% of fresh water is present in this planet. Next we're going to tackle is how to measure the impact. So we have learned so far that with industrialization, we see exponential growth in a population. And there's a lot of factors causing environmental degradation, and there's no equal impact to the environment. So one way to measure that is using the IPAT equation. This equation is widely used for simplification of the factors causing environmental degradation. On the left side, we have the impact. We then have the population. So in other words, the bigger the population is, the larger the impact. Next is affluence. This is the consumption per person. So if you have a house, several TVs, many cars, so you are probably going to have more affluence. Lastly is the technology. It depends on what technology that is, because some technology can actually help the environment. So I'm talking about destructive technology. According to the Worldometer data, the population in the world by 2020 is currently growing at a rate of around 1.05% annually, down from 1.08% in 2019, 1.10% in 2018, and 1.12% in 2017. The current average population increase is estimated at 81 million people per year. It's slowing, so it was said that the growth rate is slowing, but we are still growing. Okay, look at this projection. The blue color represents the population in more developed countries, while the green color represents the population in less developed countries. As we've observed at this projection, the population in more developed countries are more stabilized because they have less children, and that is the way of their lifestyles. While in less developed countries, they grow so fast and get higher rate because not everyone has the access on contraceptions, family planning, or not everyone is into abortion. And speaking of countries, here's the list of 5 most populous countries in the world. And today, China is the first on the list with 1.4 billion people, followed by India, US, Indonesia, and Pakistan. India is expected to add nearly 273 million people to its population between now and 2050. That means that India will overtake China and remain the most populated country to the end of the current century. China's population in 1955 are 612 million. In 1990, there are 1.1 billion and 1.4 billion in 2020. Look at this another projection. United Nations projection is that China will drop its population to 1.3 billion in 2050, and by 2100, their population will drop at 1 billion. Their annual growth rate is estimated to get more lower than the current rate, which is 0.39%. China's population is slowly decreasing, and that is a success story. Because one reason is that they implemented the one-child policy. This policy was a program in China that was implemented by the Chinese government in 1979 in order to limit their population. They are required to use contraception, abortion, and sterilization. This policy also required married couples to go through a complex bureaucratic process to apply for a family planning service certificate once they learned for a pregnancy. And once a couple had been granted to have a child, they had a duty to prevent further pregnancies. And then, in 2016, the China abolished its one-child policy. So, married couples can now have 2 children, and through the step has not significantly changed the country's birth rate. Let's proceed to the term carrying capacity. This is the maximum number of a species or human population that an environment can support indefinitely. Every species has a carrying capacity, so even humans. In this simple representation, this T represents the time in years. N is the number of population, and K for the carrying capacity. So when this curve reached or exceeded the carrying capacity, water, food, shelter, and resources will be very limited. So if we can feed people, then we're going to have mass famine and food shortages. But many scientists think that Earth has a max of carrying capacity of 9 to 10 billion people. Next that we need to consider is our ecological footprint, which is a measurement of anthropogenic impact on Earth. Today, our global footprint is in overshoot. So, it occurs when human demand exceeds the capacity of the world. So, in other words, humanity's ecological footprint exceeds what the planet can regenerate. Our planet does not have the biocapacity to sustain our current levels of growth and resource consumption. So what can be done to minimize our impact to the environment? According to mathematical biologist Joel Cohen in his book, How Many People Can the Earth Support? There are 3 paradigms. First, bigger pie. Second, fewer forks. And third, better manners. First is the bigger pie, which means the new technology and innovation to increase productivity. Here's an example of Norman Borlaug, a well-known father of Green Revolution. Way back in World War II, the issues with food caused famine all over the globe. So Norman invented the hybrid dwarf wheat. That is through breeding 2 special wheats. He took the wheat with high yield and he mixed it with wheat that was short and stocky. What happened next is it lifted people out of famine. Next is fewer porks, which means is to reduce consumption and slow population growth because the earth doesn't get any bigger. We just use the things that are here over and over again. We have what we call fertility replacement level. This is the total fertility rate or the average number of children born per woman, at which a population exactly replaces itself from one generation to next without migration. The ideal number of children to stop worldwide population that is out of control is 2.1 children per family. If this is the average number of children every family had, the population will drop, then it would never increase and stabilize at its current level. This world would be a sustainable population. This rate is roughly 2.1 children per woman for most countries, and although it may modestly vary with mortality rates. Lastly is the better manners, which means changing global culture. Because we need a global culture that needs to adapt to how we have to live on this planet, including things such as eliminate violence and corruption, improve trade operation of markets, and government provision of public goods, reduce the unwanted after effects of consumption, such as environmental damage, and achieve greater social and political equity between young and old, male and female, rich and poor. There's no exception, and the world might be borderless. Another thing that we need to know is the 9 planetary boundaries that we, humanity, must respect to keep the planet habitable. Planetary boundary framework defines a safe operating space. Again, a safe operating space for humanity based on intrinsic biophysical process that regulates stability of the Earth system. This framework aims to help guide human societies away from such a trajectory which we can continue to develop and thrive without putting our society as well as the environment at risk. And it has 9 boundaries: 1 climate change, 2 novel entities, 3 stratospheric ozone depletion, 4 atmospheric aerosol, 5 ocean acidification, 6 biochemical flows, 7 freshwater use, 8 land system change, and 9 biosphere integrity. And we will discuss these 9 boundaries one by one. Let's start with the climate change. Recent evidence suggests that the Earth is now passing 390 parts per million by volume of carbon dioxide in the atmosphere. This has already transgressed the planetary boundary and is approaching several Earth system thresholds, which means that the Earth system is in much warmer state because we have reached a point at which the melting of polar sea ice is almost irreversible. Also, another example is the destruction of rainforest or releasing methane from tundra soil. Next is novel entities, such as organic pollutants, radioactive materials, nanomaterials, and microplastics. This could have severe effects on ecosystems far removed from the source of the pollution. For example, including genetic damage, cancer, and infertility of an organism. At present, we are unable to quantify a single chemical pollution boundary, although the risk of crossing Earth system thresholds is considered sufficiently well defined for it to be included in the list as a priority for precautionary action for further research. Next is the stratospheric ozone depletion. This ozone layer in the atmosphere filters out ultraviolet or UV radiation from the sun. If this layer decreases, increasing amounts of UV radiation will reach ground level. This can cause a higher incidence of skin cancer in humans as well as damage to terrestrial and marine biological systems. Because of all the actions taken as a result of the Montreal Protocol, we seem to be on a path that will allow us to stay within this boundary. For who doesn't know, Montreal Protocol is an international agreement made in 1987. It was designed to stop production and import ozone-depleting substances and reduce their concentration in the atmosphere to help protect the Earth's ozone layer. This one is atmospheric aerosol. An atmospheric aerosol planetary boundary was proposed primarily because of the influence of aerosols on Earth's climate system. This is the microscopic particles in the atmosphere that affect climate. And also, aerosols can have deadly effects on living organisms, including humans. Next one is ocean acidification. Around a quarter of the carbon dioxide that humanity emits into the atmosphere is ultimately dissolved in the oceans. Here it forms carbonic acid, altering ocean chemistry and decreasing the pH of the surface water. When they lower the pH of the surface water and thus prevent the growth and survival of such organisms as corals, shellfish, and plankton, leading to global knock-on effects on fish stocks. And also, the amount of available carbonate ions is reduced, which is an essential building block used by many marine species for shell and skeleton formation. Biochemical flows. This is the phosphorus and nitrogen cycle, and we all know that nitrogen and phosphorus are both essential elements for plant growth, so fertilizer production and application is the main concern. This cycle is radically changed as a result of industrial and agricultural processes. What happened is when the biochemical flows is imbalance, it becomes a pollutants to air, water, and soil. It also creates local shortages and abundance as well as affecting ecosystems and food sources. Next is the freshwater use. The freshwater cycle is strongly affected by the climate change, and its boundary is closely linked to the climate boundary. Yet, human pressure is now the dominant driving force determining the functioning and distribution of global freshwater systems. Research is now showing that global freshwater consumption has already pushed beyond its boundary because, as you remember, we have only 1% of freshwater in this planet. Land system change. Land is converted to human use all over the planet. Forests, grasslands, wetlands, and other vegetation types have been converted to agricultural land. This land use change is one driving force behind the serious reduction in biodiversity, and it has impact in the crucial flows of carbon, phosphorus, and nitrogen. Lastly is the biosphere integrity. The Millennium Ecosystem Assessments of 2005 concluded that changes to ecosystem due to human activities were more rapid in the past 50 years than at any time in human history, increasing the risk of abrupt and irreversible change. The concern in this is the biodiversity loss and species extinction because the increasing demand for food, water, and natural resources has been causing severe biodiversity loss and changes in ecosystem services. Humanity is already existing outside the safe operating space for at least 4 of the 9 boundaries, that is climate change, biodiversity, land system change, and biochemical flows. The best way to prevent overshoot, researchers say, is to revamp our energy and food systems. In 2021, 3 meetings offer chances to avoid planetary boundary overshoot. Agreements with measurable, implementable, verifiable, timely, and binding targets are vital, say advocates. The first meeting is the Convention on Biological Diversity meeting in Kunming, China. This was originally scheduled to take place from 15 to 28 of October 2020, but was postponed on 23 March 2020 in the light of COVID-19 pandemic. So these meetings will take place instead from October 11 to 24, 2021. This is also called the COP16. Second meeting is the COP26. This meeting was originally scheduled to take place from November 9 to 19, 2020, but they decided that it would take place from November 1 to 12, 2021. Third one is the pre-summit of the UN Food System. This is also a 3-day event that will deliver bold new ambitions. So the event focuses on global efforts and contributions to transform food systems. They already announced that the event will be in Rome, Italy, from July 19 to 21, 2020. This is the last portion of my presentations, and we will get back to the question, how many people can the Earth support? Researchers warn that the planet Earth cannot sustain 11 billion people. Is it true? Honestly, based on my research, there's no absolute answer for that, because researchers and experts are still studying on this. But according to studies, it is estimated that 1/3 or 2.6 billion of current population can Earth sustain for a long term. Just for a long term. And the United Nations Global Environmental Service looked at dozens of papers from the last 30 years, and they organized the estimates into this amazing graph, showing that this echoes we can support 8 to 16 billion people. Statistics shows that in the developed country, the average number of children per families are having declining. Most populous countries are now decreasing their growth and fertility rates, just like the case study of China. Some optimistic estimates population will stabilize at around 9 billion. If we are be able to be sensible about our consumption of resources and prevent waste whenever possible, then the Earth can absolutely support 9 billion. And studies by the UN shows that the fertility rate in the majority of the countries is slowly decreasing. So, we might never reach 10 billion. Overall, the world population is overpopulated, but can possibly support 10 billion people based on its carrying capacity. I will end my presentation at this quotation: we do not live in a robot, we live in an ecosystem. It's all about balance. Thank you, everyone.